Okay, second lesson on the circle theorems. Okay, I expect you've already done the first one, so I expect you know the first three theorems, which is the angle of the centre is twice that angle of the circumference. Angles in the same segment are equal, and it's an extension of the first one. But if you've got a diameter and you've got a triangle and the triangle reaches the circumference, it has to be a right angle triangle. It's impossible not to show this otherwise. Right, next one we'll do today is this one here. This is a silic quadrilateral, and what a silic quadrilateral means is that all my vertices on the quadrilateral hit my circumference of the circle, and the opposite angles in a silic quadrilateral add up to 180. So this one here, it's a silic quadrilateral, all the angles are on the circumference. So if this is 91, my opposite one, which is going to be that one there, must be 180 take away 91, which is 89. This is 40, my opposite one is there, so it's 180 take away 40, which is 140. Again, this is a silic quadrilateral, they all touch it, so if it's 110, that's y. I've got to do 180 take away 110, which means that one there's 70. But the same as this is 85, I've got to do 180 take away 85, which is 95. So one's got to be 95. Okay. I think we get the idea of this. If you wanted to copy down, pause it and copy down this example so you know exactly what's going on. Here's some questions. First one start off quite nice, easy, but then you're going to have to start using the previous circle theorems to answer these. And this can get quite tricky, and you have to give reasons as well in an exam. So I'll give you a bit of time to do this. Pause the video if you want. Okay guys, here's your answers. Cross your work. Right, the second one. Right, if I've got a chord and I've got tangents, yeah. So any chord is just any line that goes from one circumference to the other. Right, a tangent. Now tangents are always badly explained, because the circle theorem actually is if you draw a line from the radius to the tangent, this is going to be 90 degrees. And people always think tangents are 90 degrees. They're not. What this is, this tangent here is actually going exactly the same direction as that point where it touches in the circle. So that little bit of the line actually goes the same direction as a tangent. It just happens to be 90 degrees of your radius. It gets a bit, people get confused when they do a bit more maths later on. Right, so tangent 90 degrees as I said. Right, now, if I've got two tangents from the circle and they meet here, those two tangents must be the same length. Okay. And by the same logic, that if you split them up, the size is going to be half. Okay, we can do one more thing with this. If I join these up to the centre, I actually know that's going to be a right angle, and I actually know that's going to be a right angle. And by that logic, I can work out this degree. Yeah, because I know that 90 plus 35 plus whatever the hell this is must equal 180. Yeah, and I can work out all of this. Okay. Copy these two down, you need to know them both. And here's some questions for you to do. What you have to remember is tangents meet at 90 degrees, yeah, and chords also meet at 90 degrees. Pause the video if you want, I'm going to show you the answers. Here you go. Take cross work. Okay. I've already talked about the chords, so I'm going to talk about that one again. Right, alternate angle theorem. It's actually quite nice, I quite like this theorem. Now what it means is that this angle here, the green one, is exactly the same as the other green angle. Okay. And so by extension, that one there must also be the same as this one here. So they sort of alternate. And if you think of this as like A, B and C, that must equal 180. So if this one here is B, that one here is C, that one here is A, that also equals 180. Right. Yeah, just showing you what the segments are like. So if we go to this one here, if this is 60, if I look at the alternate angle that's there, which is one that's labelled as theta, that must also be 60. Okay. I've got a link here actually, which I'll include at the end of the slide. And if you go through them, it shows a nice graphical way of just showing how these work. And you can move these around just to see how nice they are. The only error that happens is here is if that one there. Now it's actually drawn accurately, and then what you might think is that's a right angle. Yeah, but it's not, because this isn't actually a diameter, it just looks like a diameter. So just please be careful for that. So guys, here's some questions just before, so you can go. Ignore that. That's everybody's got a zebra book. Okay, I'm going to show the answers. There you go. Sorry about the bad handwriting. Okay, and here's some exam questions, just in case you want to just go for it. I'm not going to show the answers to these. If you enjoyed that.